Right, grade 12s, in this lesson what we're going to be focusing on is using calculus to sketch graphs. And if we start off with, let's say we start off with the parabola, because we're going to extend this into other graphs, specifically a cubic graph. Don't worry about that at this stage. But let's go back and revise our good old-fashioned parabola. Okay, so let's take our parabola and we'll take an example of x squared plus 2x minus 3. And what we want to do is we want to focus on the turning point of this graph. We will sketch it, but I want to show you the coordinates of how to get the turning point of this graph. Now, there are many different methods, and I'm going to do a few. The first method that you did in grade 11 was to complete the square. Now, how did we do that? We said x squared plus 2x plus half the coefficient of the x, okay, squared, and then we subtracted that because we weren't allowed to keep it in, and then we subtracted 3. And that then gave us x squared plus 2x. A half of 2 is 1, 1 squared is 1, subtract 1, subtract 3. That was a perfect square, which gave us x plus 1 squared. Okay, then we've got this giving you negative 4. Okay, the turning point, if you remember from grade 11 days, is you go x plus 1 is equal to 0, and you solved for x. So you got negative 1, it was a different sign, and the y value of the turning point was minus 4. Okay, and that was your turning point, completing the square. Not a very favorite method, but one method anyway. There was another method that you did use, and that was the formula x is equal to minus b over 2a. Alright, now how do we do this? We have our little parabola here, 1x squared plus 2x minus 3, and if you remember, that was a and that was b. And then we said, okay, x is equal to minus b over 2a. And that came to classically negative 1. And of course, to get the y value of the turning point, well, you substitute minus 1 back into the original equation there, leaving you with positive 1, minus 2, minus 3, which gives us negative 4. And once again, you have a turning point at minus 1, minus 4. Now, the third method for me is more exciting. It's the using of calculus, in particular the use of the derivative. Now, before I even do this, I want you to look at a parabola graph. Okay, that's the graph of our parabola. It's happy. What do you know? What goes on at a turning point? Well, let's go away from the turning point. The gradient of the tangent is negative there. It's going down, decreasing. The graph's decreasing. To the right of the turning point, the gradient of the tangent is positive, so it's increasing. But at the turning point, the gradient is 0. Why? Because the gradient of the tangent is 0 because it's a horizontal line. Okay, now, if we take our parabola's equation, here it is. Now all I'm going to do is I'm going to differentiate this thing. Okay, so I'm going to get x squared becomes 2x, then the 2x is 2 minus 0 for the negative 3 there. Then at a turning point, the gradient is 0. Now all you have to do is solve for x. Bring the negative 2 across, divide both sides by negative 2, and look at that. You've again got your x value of the turning point. With all the other methods, x was negative 1. For the minus b over 2a, x is negative 1. For this third method, x is negative 1. And all you would then do is go back to the original, and as you did previously, you plug it in, and there you go. And what you have is then the turning point of the parabola, okay, using calculus, and this is the most favorite method that I can think of. Just by the way, something interesting, if you did have to sketch this graph, watch here. I want to show you a fourth method, but it involves getting the x-intercepts. How do we get the x-intercepts? Well, we let y be 0. And then how did we do this? We then factorized, and of course we had our x y-intercept. The y-intercept, as you probably realize, is where x is naught. It's the coefficient there. Now, if we sketch this graph, I just want to get a set of axes quickly. And if you have a look at this, what is actually very interesting is that if you just go up, say 1, 2, 3, minus 1, minus 2, minus 3, and down to 1, 2, 3, 4. Remember, your one x-intercept is your y-intercept is negative 3. The turning point was at minus 1, minus 4. That was naught, negative 3. And then your x-intercepts were at 1 and negative 3. And of course it's happy, so your parabola would have done this, comes down, up we go and turns, and that would be the graph of the parabola with its axis of symmetry through negative 1 here. There we go. And that is x equals negative 1. Your y value here is negative 4, and the gradient of the tangent is 0 at this point. Remember, f of negative 1 is negative 4. It's the y value corresponding to x equals negative 1. But the gradient at negative 1 is naught. Okay, now there is a fourth method that you might want to use if you've got the x-intercepts. What this method involves, it says take the x values or the x-intercepts, add them up and average them. Now look at this. Minus 3 plus 1 is negative 2 over 2, which is negative 1. Now look at that. There is negative 1. It's the halfway mark between the x-intercepts. A wonderful method. And of course you can easily get your y by subbing into the original equation. So be careful with that thing. This is, if you've got the x-intercepts, that's very quick. You must know the calculus way of doing it as well, because that's very, very important.